Today we're going to be looking at the mathematical operators. I've sprinkled a few of them on the screen. They're a little. The first thing that we're going to look at is types of division. You'll notice that on your handout you have 3 examples for the 3 kinds of division. The first one is called real division, and this is the type of division that you are all familiar with. You punch the numbers into your calculator, it spits out a decimal result. Then there's this other concept, which we call integer division. The result is going to be slightly different from what you'd expect. It's still approximately the same. The previous answer was 3.4. This answer is 3. And if you remember from grade 6, your long division steps, integer division gives you the quotient. What does it mean when it says it returns the quotient? You'll notice on this slide, this is an example of long division. The quotient is that number above the bar. Let's go through an example of long division to refresh your memory about what it is. Let's take our example of 17 divided by 5. It's going to become 17 with the nice lines that we're so familiar with for long division, 5. So 17 divided by 5. Our first try is to calculate 1 divided by 5. That doesn't work. You can't divide 1 by 5. How many groups of 5 are there in 1? Well, we can't do that. Then we add the second digit of our dividend. 17. 17 divided by 5. 1 times 5 is 5, 2 times 5 is 10, and so on. Which one of these is closest to, but not larger than 17? That's the third possibility. 3 times 5 is 15. We're going to subtract 15 from 17. We end up with 2. Is this familiar? Excellent. In my class, I'm seeing lots of thumbs. These two numbers, the divisor and the dividend. These other two numbers, the quotient and the remainder. So the quotient tells you how many groups of 5 there are in 17. There are 3 groups of 5 in 17. The remainder tells you how many are left over. What I am showing you today is that the computer can very easily give you both the quotient and the remainder. Those are the 2 other types of division that we're talking about. So first I showed you real division. That gives you the decimal. It's a real number. Then I showed you the integer division, which gives you the quotient. How many groups of 5 are there in 17? Please notice that it's not rounding. You don't have to worry about rounding in here. It's giving you the number of groups of whatever. So that's the quotient. The last thing I'll show you is how to get the remainder. That's the third type of division. For that one, we have modulus. We call it modulus. It is a type of division. 17 mod 5 gives you the remainder. It tells you how many are left over when you find the number of groups. So here's a quick summary of the 3 types of division. The first one's called real division. The second is integer division, and it returns only the quotient. The last one is modulus, or modulo sometimes, and it returns the remainder. You don't need to copy this down because it is already on your sheet, although you can if you want to. Remember Bedmass from math class? Well, we are going to expand it. Instead of just Bedmass, we are going to add a few items here. In math class, you learned about Bedmass, brackets, exponents, division, multiplication, addition, and subtraction. On a computer, we have to modify this. And that's what you are seeing here. Like in math class, we have BEDM, brackets, exponents, division, multiplication. We add a new order, a new precedent. Integer division comes after division and multiplication. And then in Visual Basic, we have modulus, which happens after integer division, but it happens before the step of addition and subtraction. To help you memorize it, you can think of Bedmass. So Bedmass, brackets, exponents, division, multiplication, integer division, modulus, addition, subtraction. As long as you learn Bedmass, this should not be a stretch in terms of your learning. You can see the rules in the box. Evaluate the operator with the highest precedence first. If there is a tie in precedence, work from left to right. This is something that you've been practicing for years in your math class after having learned Bedmass. Intuitively, we work from left to right in the English language, so that makes it easy. Let's take a look at the examples that are here. I would like you to try your hand at solving these before I show them to you. That way you can compare your predictions to what I am going to show you. Before we get started here, I'd like to remind you that you will not be getting calculators on the test. We try to design our questions so that you don't need calculators. If you feel like you need a calculator, it probably means that you are missing the point of the question. We try to set our questions up that they can all be solved with fairly simple mental math. Our first example, 6 plus 7 times 8. This requires you to think about conventional Bedmass. Multiplication has a higher precedence than addition, so we multiply 7 times 8 to give us 56, plus 6 gives us 62. In our second example, we are told using brackets what the precedence is. Brackets make our lives and the lives of others easier because you take the guesswork out of things. In this case, we are told first add 6 plus 7, then multiply by 8. And that'll give you 104. So 13 times 8 is 104. Exponents go first. 4 to the power of 2 is 16, and then we multiply by 3 to give us 48. The next one is interesting because it's the first time you've seen mod in action. For example 4, you start off with 113 mod 20. 20 goes into 113 5 times, 5 groups. It leaves you with a remainder of 13. 13 mod 5, you have 5 groups. Sorry, you have 2 groups of 5 can go into 13, leaving you with 3 as the remainder, or as the result and the remainder. Oops, and I just exposed the next question. For example 5, the brackets tell you the precedence. 20 mod 5 is 0 because you can have 4 groups of 5 going into 20 with 0 remainder. 113 divided by 0, how many groups of 0 are in 113? You could argue an infinite number. As far as a computer is concerned, that is an error. And as far as mathematicians are concerned, that is an error. Let's try the next one. We are combining Modulus with integer division in this case, not just regular division. For example 6, we look at precedence. Integer division is higher up the list than mod, which means 8 integer division 2. 8 divided by 2 is 4. Then we take 60 mod 4. How many groups of 4 are there in 60? 15, with no remainder. Example 7. The brackets tell us precedence. They force us to deal with mod before integer division, despite the fact that integer division comes before mod. So in this case, 60 mod 8. How many groups of 8 are there in 60? There are 7 groups of 8 in 60. 56. 7 times 8 is 56, which leaves us with 4 as the remainder. 4 divided by 2 is 2. So now you can see how precedence matters. Example 6 and 7 are very similar, except for the use of the bracket. Example 8. 50 divided by 2 is 25. That's an easy one. 25 divided by 2, which is an integer division, gives us 12. We lose the half. Now for exponents. In the case of example 9, we have what seems like a very complicated line, when in actual fact the result is going to be very simple. It's going to be a 1. 63 to the power of, a whole long bracket. 2 to the power of 4, subtract 4 to the power of 2, which evaluates 2. 16, subtract 16. When you subtract 16 from 16, you get 0. 63 to the power of 0 evaluates to 1. Any number to the power of 0 is always going to give you the result of 1. I guarantee you, you will see a question like this on your test. I guarantee it. The reason I can guarantee it is because I will put it on there. The last one requires you to realize that integer division has a lower precedence than multiplication. So first we multiply 2 by 4, and then we are going to take 44 divided by 8. 44 divided by 8 is 5.8, but we're not worried about the decimal. We're only worried about the integer, so the result is 5. These are the examples. Now, we've got a worksheet that you are going to do. And on the worksheet, I want you to do everything except the very last question. That's the programming question. The homework that accompanies this video is on the worksheet Arithmetic 1. We've got questions 1, 2, 3, and 4. And on the back, you will find question 1. You don't need to do question 2 in this case, at least not yet. Though if you want to, it certainly is an extension opportunity for you to try your hand at code.